Welcome to the second video on JawsJS. Now we're starting again with looking at the index.html file, just as a quick review that uses the canvas element and that we specified has a fixed width of 500 pixels and a height of 500 pixels. We're also using the memified version of JAWS, and we're including game.js as the logic for the game. Now moving over to the JS file, we see again it uses the PlayState Function, as I talked about in the first video. But this time we have three variables. We have player, goal list, and field. Now moving down to the setup part of the PlayState Function, we see player now has some additional properties. Not only is it being defined as a sprite, but we're also saying it has a speed, it has a dx, and it has a dy. Defining speed as a property of player allows us to change the number of pixels that the player sprite moves when the player presses a button. Dx, dy are the amount of change for x and the amount of change for y, a delta x and a delta y. We're also defining player to have the property of move, and move is a function. Now within the move function, it has this functionality. Each time it's called, the x position of player is updated by the amount dx, and the y position of player is updated by the amount dy. It also has these four conditionals that check to see if the player.x is less than 0, if it's greater than the width of the canvas element of the jaws.width, if the y is less than 0, or if the y is greater than the height. The reason why I'm not just checking against jaws.width or jaws.height is because the position of the sprite is drawn from its upper left-hand corner, just like the coordinate system of the graphics library. Otherwise, if I just checked against the width or the height, it would seem to disappear when it exceeded those, because the check against it wouldn't happen until it had passed outside of the drawing area. So we check against, making sure that it's not greater than the entire width of the player sprite minus the boundary of the jaws.width for the width and for the height. At the end of the player move function, we're also resetting the dx and dy to be 0. Whatever we moved for x, or whatever we move from y, is reset to 0 each time. Now moving down to goal list, we see that goal, instead of being just another sprite as it was in the first video, is now a sprite list. Basically an array of sprites. In fact, that's what we're doing right here in this short for loop. Running 5 times from 1 to 6, it is populating goal list, pushing a new sprite each time, be equal to 80 times 1 and then 80 times 2, so that all of the gold sprites in goal list are along a diagonal. We're also adding a property to the SpriteList goal list called check. This is using a different colliding function than the last video. The last video used collideOneWithMany, which returned either true if the two items were colliding or false if they weren't. In this case, we're using collideOneWithMany. CollideOneWithMany does, well, exactly what it says. The first argument is one sprite or other object, and then it checks to see if it is colliding with the many, an array, usually a sprite list, of other objects or sprites. What it returns, though, which is different from collideOneWithOne, is an array. either an empty array, meaning no collisions were detected, or all those items that collided with the first argument from the second argument. So then we check, once we have results, to see if any, results were found. If the length is greater than 0, then it has some entries within it. Its length is greater than 0. It's not an empty array. We're using the remove function and checking it with the first entry, 0, because arrays start with the 0 and not with 1. And if it exists within the goal list is to remove it from its entries. Now the final part of the setup is a field. In this case it's green, and it starts at 0, 0 and extends all the way to the width and all the way to the height. Moving down to update, we see what was gone over in the previous video. Up, left, down, and right. But this time, instead of decreasing by a fixed number, we're decreasing by a variable, player speed. And each time, dy or dx is being updated instead of x or y direct. Then at the end of these conditionals, we see player.move is being called, as was previously gone over, and the player X or player Y is being updated accordingly. And then goalList.check is being called, as was just gone over, to check to see if player is colliding with any of the entries within goalList. We also see that the draw order has changed slightly. Field is now the first thing being drawn, and then the player, and then the sprites within the sprite list, goal list. Now to show you what that looks like, we can run the project, calling Firefox to look at it. And it looks like this. We see the green field sprite being drawn as the bottom layer. It is drawn first. Player is drawn second, and goal list is drawn third. We can also see, if I use the arrows to move the sprite around, that the conditionals within player.move is preventing the sprite from exceeding the field. From exceeding 0, or JawsWidth minus player.width, as the farthest on the right-hand side, or the farthest going down. Now we can also see, for each game tick of update and then draw, it is checking to see if player is colliding with any of the entries within goal list. At the moment, it's not. However, if I do, you'll notice it got removed. This conditional became true. The results from the calling of the function collideOneWithMany, player against goal list, resulted in results being assigned to be an array that had a length greater than 0, and then the first item in that array was then removed from goal list. And as we continue to play, you can see we remove them one at a time until they are completely gone. We can also see how, just moving from the first video to the second video, it's now looking a lot more like a game, even though we haven't added much more than some simple controls and a function per object, or per set of objects. One for goal list, checking for collision, and one for player, allowing it to be moved and then confined. In the next video, I'm going to go over images. We're going to finally move away from colored squares. I'm also going to go over a viewport as a way to make the game world bigger than just the canvas size, and allow the canvas size to be a view or a window into a larger world. Thanks for watching.